Okay, so this is Balancing Chemical Equations Part 3. So hopefully you've watched the first two and mastered that technique. So now I'm going to teach you some more advanced techniques, although you're basically kind of doing the same thing. So here we have a reaction. Silver iodide reacts with iron carbonate to yield iron iodide and silver, carbonate, I believe. Yeah. Okay, so then basically we're going to do the same thing we did before, and then I'll teach you another technique. It's a little more advanced. But we normally do our silver, iodine, iron, carbon, and oxygen. Okay, so there's a lot of atoms there. Okay, so let's write down everybody. One silver on the left, two on the right. How many iodines? One here, three here, two irons here, one here. How many carbons? That'd be three. So three times one is three carbons here. How many carbons on the right? That'd be one. How many options on the left? 3 times 3 is going to be 9. So there's actually 9 options here on the left side. How many options on the right? That would be 3. So clearly we are unbalanced. Okay, so where do you want to start? I probably want to start with the odd numbers, probably with the 3 here because this is such a big number, the 9. So that's usually kind of the problematic number. So what we can do is, there's only an option here, not here, so we would basically have to put a 3 here. So that would give us 9 oxygens, right? So that's good. But then we got to change these other numbers now. 3 times 2 is 6. So now we have 6 silvers, but we also have now 3 carbons. That's actually good because now our carbons and our oxygens are balanced. But now we have to balance our silver on the left side. We have 6 silver on the right, so we basically need 6 silver on the left. So that's going to change this to a 6, but also that to a 6. And let's see, now we need to change our iodine and iron. So let's go to the right side now. So let's see, so we want to put a 2 here because 3 times 2 will give us 6 irons. So it could be 6 there, and then we have to change what the number of, I'm sorry, that was iodine, I'm sorry. 2 times 3 is 6 iodine, and then here we have 2 irons. So now we appear to be balanced, if you can see that. So 6, basically there's a 1 here. 6, 1, 2, 3. Okay, so that's kind of the old way of doing it. Now it's a little slow because you're writing down every single atom. So one thing you can do is group the atoms together as long as all the atoms are kind of in one location, okay, so to speak. So that might sound confusing, so I'll try to show you how that works. But basically you want to memorize or write down the solution 6, 1, 2, 3. So I'll write that down maybe over here, 6, 1, 2, 3, just to make sure we get the same answer as the first time. So get rid of all these numbers. Okay, but hopefully it should be a little faster now. So notice on the left side, we have only silver here, nowhere else on the reactant side. Okay, but that's silver by itself, so we can just put the Ag still there, and then same with iodine, iron, but here's where it's going to be different. So you have CO3 here, there's no carbon or oxygen anywhere else here. But over here, you also see there's a CO3 here. That didn't change at all, right? And again, there's no carbon or oxygen over here. So instead of putting carbon and then oxygen separately, we can actually just put CO3 as one molecule and combine the 2 atoms into one molecule. So that means we don't have to really count individually the carbons and oxygens. So it should speed things up just a little at least, right? So how many silvers? 1 here. We have 2 there. How many iodines? 1 here. 3 iodines here. 2 irons. 1 iron. So how many carbonates? We have 3 carbonates. That's what this 3 down here means. 3 of these guys on the left side. 3. Okay. So now how many carbonates on the right? Just 1. Right? So that saves us ourselves a step because we don't have to count the individual carbons and individual oxygens. Again, this only really works if you only have the carbon and oxygen in one location on each side. So like there's no carbon oxygen here, so we don't have to worry about that. There's no carbon oxygen here, so we can do this. Okay, so let's start balancing. So basically we have 3 of these on the left, so we need 3 of them on the right. So let's put a 3 here. So that fixes that problem. But then we have to change this number, so it'd be 6 silvers, right? So now we got to fix this over here, so we need a 6 here. So that's going to change our silvers and iodine. So 6 silver, 6 iodine. And now we need to fix our iodine and iron on the right. So we need to put, was it a 2 there, I think? Yeah, 2 irons and then 6 iodine. And then it looks like we are balanced again. And did we get the same numbers as last time? Last time we got 6, 1, 2, 3, and now we're going to get 6, 1, 2, 3. Okay, so we did it correctly. Now you don't have to do it that way, and it might be more advantageous to do that when you have multiple ions. Here it was just kind of combining 2 atoms, but sometimes you'll have another group here. You can do that for 2 different molecules, so that'll save you some time. So let's try another example. This one's probably going to be a little more challenging. So let's try C2. C2H6 plus oxygen yields space carbon dioxide plus, let's see, H2O. Good old H2O. Whoops. Okay, all right. So I don't think we can use that last technique I showed you, but this problem is just going to be a little more challenging, so we'll just do the normal way. Carbon, hydrogen, oxygen. So 2 carbons, 1 carbon, 6 hydrogens, 2 hydrogens, 2 oxygens, and 3 oxygens. Okay, so again, usually this is kind of the problem. So I'm going to put let's put a 2 here, because this is the odd oxygen. This is an even oxygen, so you usually want to get rid of the odd number atom. We got to change those numbers now, so now we get 2 plus 2, 2 oxygens plus 2 oxygens is going to be 4. But now we have to change the number of hydrogens, so that becomes 4 as well. So again, we have some problems now because still everything's not balanced. So what I can try to do is balance the carbons. Since I just started on the right side, let's just keep on the right side. Put a 2 here. So that would be 2. So now we have to change the number of oxygens. So 2 times 2 is 4, plus another 2 oxygens here. So that'll be 6 oxygens. And okay, so now we still have some more problems, right? So now we got to increase the number of hydrogens on the right still because we want 6. So actually that means this will become 3. So then we get 6 there, but now we got to change the number of oxygens. But now we have a problem because now we have 3 oxygens plus 4 would be 7, I believe. 7 oxygens, that's right. Okay. Well, let's try balancing. Well, you notice that the carbons are balanced and the hydrogens are balanced. The only thing that's not balanced is the oxygen, right? But notice that on the left side, if I put an even number here, this is only going to be even. If I put a 2 here, that's going to be 4. If I put a 3 here, that's going to be a 6. If I put a 4 here, that's going to be an 8, right? So the number of oxygens on the left will never be odd to match this one, unless I use a fraction. So the easiest way to do that is say, okay, what number times 2 will give us 7? So basically, if you think about it, it's going to be like 3.5 times 2 is 7. Well, 3.5 is what fraction? 7 over 2. So we can put 7 over 2 here. And if you think about it, 7 over 2 times 2, well, the 2 in the denominator here and the 2 in the numerator here cancel out. 7 over 2 times 2 will become 14 over 2, which becomes 7. So 7 over 2 times 2 is 7. So that will give us 7 here. So notice that we are now balanced, right? But you're not allowed to have non-integer numbers for the coefficients, and that's definitely not an integer. That is a fraction or decimal. You're not supposed to have those. But all we have to do to get rid of it is get rid of that 2, so we do that by multiplying every single coefficient by 2. And now there's basically a 1 here, so 1 times 2 will become 2. And then you multiply this by 2, so that becomes just a 7, a normal 7. You got to multiply this by 2, that becomes a 4. Multiply this by 2 and you get a 6. And if you want to double check my math, you should see that everything is balanced. So just for speed's sake, I'll just look at the carbons. 4 carbons here, 4 carbons here, 12 hydrogens on the left, 12 hydrogens on the right, And where are my oxygen? We have 14 oxygens on the left. We have 8 oxygens here, but another 6 here. So 8 oxygens plus 6 oxygens is going to be 14 on the left and 14 on the right. So that means we are all balanced. Okay, so hopefully that made sense to you.